Hello, 8th grade math students. Mr. Lawrence here. Well, I'm not really here. You can't see me, but you can feel my presence. Well, maybe you can hear my voice. At least you can't smell me, right? Hey, anyway, I've got a really cool lesson planned for you today. We are going to be using linear equations. Remember, a linear equation is an equation that makes a line. Linear. You know, the root word of linear, no, Nadim, it's not ear. No, it's not. It's line. The root word of linear is line. So a linear equation is going to make a line. And these equations are going to be in this form called y equals mx. And you're going to be seeing this a lot. This is heavy algebra stuff, ladies and gentlemen. This is getting ready for the air test. This is furthering your knowledge of mathematics. This is where math starts to have meaning and purpose. And this is next year. You're going to spend so much time in with y equals mx or y equals mx plus b. We'll talk about that later on, not in this lesson. But anyway, let's get down to it. All right. Now, by the way, when you watch this video, you are to have your notebook out. You are to be taking notes. You are to pause the video often and answer questions and things like that. Do not just sit and watch the video and kind of glaze over like you're watching an old TV show, and then 2 minutes later you can't even tell me what you watched. Make sure you're taking notes. This counts, and you do have homework tonight. All right, so here we go. I'm in digits, as you can see, and part 1 is rolling up, and here it comes. Ooh, look at that speedy car go by. That's amazing. It says the graph shows the distance d, which the distance is here. Let me see, do I have my airliner? Is it working? Oh, yes it is. There we go. Can I write with it? Nope, it's not going to let me write on here, but that's okay. But what I'll do is I will get Smart Notebook open so that when I need to write, I can. All right, there it is, and I should be able to write. Oh no, we've got the spinning wheel of death. Oh dear. There we go. We've got some writing going on. Excellent. Or should I say excellent. All right, here we go. So the graph shows the distance d. A car travels in time t at a constant speed of r. Okay, the distance is here along the y-axis. Here's the distance. Mi is for miles, Minnesota, okay, or the state up north. So 0 miles, 30 miles, 60 miles, 90 miles, 120 miles, etc. Okay, and here's the time in hours. And it says 1 hour, 2 hour, 3 hours, 4 hours, 5 hours. Now this graph, some of you look at it and go, I don't know, it's just a line. No, it's not. This tells me a whole bunch of information. It says, what is the constant speed of the car? I know just by looking at this graph. Okay, first thing I want to do is I want to find 2 points. Okay, let me see if I can take a picture of this. All right, here we go. Watch, I'm going to take a picture. Ooh, there we go. I just took a picture. And now I'm going to drag that. Oh, darn, I can't drag it where I want to. All right, that's all right. Maybe we can make it work. Let me get this here. Ah, there we go. Okay, and now I'm going to be able to draw on it. So I need to make that just a teeny bit smaller. There we go. Now we can see the whole thing, and I'm going to lock it in place. All right, I need 2 points on this line. And you're saying, no, there's not any points. Yes, there are. There's an infinite number of points on here. There's a point here at 0, 0. I mean, doesn't it make sense that if you drive for 0 hours, you go 0 miles? That's what this is. Okay, no, it's not a face of an alien. That's the point 0, 0. That's the origin. In other words, I go 0 hours, I travel 0 miles. Now I can pick any other intersection of the line. I could pick this point here, I could pick this point here, I could pick this point. In fact, for what I'm going to do, I can pick any 2 points I want. Okay, but since it goes through 0, 0, that makes my math really easy. I'm going to pick 0, 0, and I'll tell you what I'm going to do. I'm going to pick this point right here. Okay, now, to get the speed of the car, what we're going to need is we're going to need something called the change in y. Yeah, that means change. That triangle means change. Did you write that down? That's change. the change in y. In other words, how much are the y coordinates changing? That is my vertical distance. That's my vertical distance. Uh-oh, I'm going to sneeze. Hold your ears. Sorry about that. Okay, and I'm going to put that over the change in x. The change in x. So I need to know the horizontal distance. Okay, how much the horizontal distance changes. Well, I know the coordinates of this point here are 4, 120. Some of you say, no, it's 124. Look, I know my alphabet, ladies and gentlemen. X comes before y in the alphabet, so this is my x coordinate, and this is my y coordinate. Yeah, this is review. You remember that, right? From when we did transformations and all that. Okay, so now, to get the change means subtract. I don't know if you realize this. If you go to the store and something costs $5, okay, and you give the person $8, okay, you give them $8, you're going to get change. It's going to be $8 minus the $5. You're going to get $3 change. You see? So change means subtract. So to get the change in y's, I have to subtract the y's. So what I'm going to do is do 120 minus 0. Why 0? Because that's an x coordinate, that's a y coordinate, and down here I have an x coordinate and a y coordinate. The more I look at this, I think it looks like an owl. Man, maybe I'm like a secret artist. I didn't even know it. Okay, I'm sure Hannah would disagree with me because she's so artistic. She's very good. I don't know if you've ever seen her artwork. I have, and I'm jealous of you, Hannah. Keep up the great work. Okay, and then I need the change in x. So I'm going to do 4 minus 0, which is going to give me 120 minus 0, over 4. 120 over 4. 120 what? Well, 120 miles. How do I know miles? Because the y coordinate is in miles. And that's over 4 what? 4 hours. How do I know that? Because the x coordinate is in hours. My answer is going to be in miles per hour. Did you see that? Miles per hour. 120 divided by 40 is 30. This car is traveling at 30 miles per hour. Yeah, that's pretty crazy. All just from that graph. So that's the answer to question A. It says, what is the constant speed of the car? All right. Now it says, how far will the car travel in 2 hours? Well, the graph can tell me, but what I would love to do is oops, wrong button. Sorry about that. I would love to make an equation. Okay? So y is my distance. All right? X is my time. My rate of change is 30 miles per hour. I'm going to write y equals 30x. Now, I can make a table out of this. I can make a table if I want. The chart's going to match up, but watch this. Okay? So if I drive for 0 hours, if I put 0 in for x, 30 times 0 is 0. If I drive for 1 hour, well, 30 times 1 is 30. Okay? If I drive for 2 hours, it's going to be 30 times 2. That's what 30 miles per hour means. It means every hour you travel 30 miles. So if you drive for 10 hours, you would do 30 times 10. So if I put 10 in my input-output table, I would multiply 30 times 10 and get 300. So in 10 hours, I would travel 300 miles if I was traveling at an average rate of 30 miles per hour. Yeah, it's pretty simple. So it says, how long will it take the car to travel 120 miles? Well, if you're looking at that table I just went to, well, let's see here. 120 miles took 4 hours. Yeah, 120 miles took 4 hours. See that? Okay. If I wanted to do it algebraically, Taylor, pay attention to this because I've been preaching algebra to you an awful lot lately. If we wanted to do that algebraically, we would take our equation y equals 30x. And if they said 120 miles, well, that's the y value. So I'm going to put 120 in for y. I'll have 30x. And then I'm going to get x alone. Well, how are the 30 and the x attached? By multiplication, so I'm going to divide. I'm going to divide by 30, and so the 30s will cancel. I'll get x equals 120 divided by 30 is 4. So the answer would be 4 hours. It's pretty simple stuff, ladies and gentlemen, pretty simple stuff. Write an equation in D equals RT form to model the situation. Well, I just kind of did that, except they want D equals RT. You recognize that from science, don't you? Distance equals rate times time? Yeah. Okay, that's actually a math equation, and science uses it all the time. They never give us credit for it. D equals RT. Well, the distance is going to equal the rate times the time. What's the rate? 30 miles per hour. The time is t. And there you go. There is your equation for part D. All right, we're going to look at the next one. Go kind of quick here. All right, and let me get a Command-Shift-4 going on here. All right. There we go. And I love my technology. By the way, you guys think math is useless, that you're never going to use it. I'm using it right now. And all this technology I'm using, this is all mathematics, applied mathematics. Without math, we wouldn't have any of this. Okay, the graph shows the distance d a train travels in time t at a constant speed r. Write an equation in d equals RT form that models the situation shown. I need 2 points. Well, gosh darn it, I'm going to use 0, 0. Whenever I can, I use 0, 0. All right? Now, I'm not going to pick this point because I don't know the exact value of the time. See, it's not at an intersection. I could pick this point. I could pick this point. I could pick this point. Let you in on a little secret. It's going to be easier if I pick this one. It's closer to the origin, and my numbers will be a little bit smaller. So remember, to calculate r is going to be the change in y over the change in x. All right? Now, the coordinates of this point are 1, 100, and the coordinates of this point are 0, 0. Change means subtract, so I'm going to do 100 minus 0 over 1 minus 0, which will give me 100 over 1, or better yet, just plain old 100, right, if I simplify that. And so the rate, r, is 100 miles per hour. Why is it miles per hour? Because my distance is in miles and my time is in hours. Miles per hour. So my algebra equation, my linear equation, y equals mx, is going to look like y equals 100x. My d equals RT form will be d equals 100. That's the rate times the time. And there you go. All right? Piece of cake. Okay, let's go on to the next one. See how far we can get through this. Okay, here comes the next problem. Maybe it'll be a lovely animation. Oh boy, I think it is. I know you're excited, Austin. Here we go. Ooh, look, the people have clothes on this time.
I think we have a problem. The freezer broke last night.
It says that all prices are 1/3 off. All prices are 1/3 off because the freezer broke. So they have to sell the food quickly or they're going to lose it. Okay, it's going to go bad and they're not going to be able to sell it. So they're going to try to sell it quickly. Now, this one's a teeny bit tricky. If everything is 1/3 off, how much do you pay for? You don't pay for 1/3 of it. You pay for 2/3 of it. They're discounting it 1/3. How did I get that? Well, I took 1 minus 1/3. Okay? Now, if you want, you can make 1 look like 3/3, because that's the same as 1. 3/3 minus 1/3 is 2/3. Now, before you try to tell me it's 2 zeros, stop and think. 1, you're never allowed to divide by 0. That would just be foolish. But 2, if I have 7 cookies and Tino comes along and eats 3 of my cookies, naughty boy, didn't even ask me, don't I have 4 cookies left? Yes, and Hope's wondering what the heck do cookies have to do with this problem? Well, when I see fractions, the denominator is the label. The denominator is the cookie. Look, this is 2/7. It's like 2 cookies plus 1/7. Okay, there's 2/7 or 2 cookies. There's 1/7 or 1 more cookie. Altogether, I must have 3 cookies or I must have 3/7. Not 3/14. That makes no sense. Now don't call this 2/7 because that's not what it is. It's 2/7. 2/7 plus 1/7 is 3/7. I almost said 3 cookies. Just like 2 pops plus 1 pop are 3 pops. It's the same logic. So the denominator is the label. Okay, so let's go back to this. So if you were paying 2/3 of the price, your equation is quite simple. It's going to look like y equals mx. So y is going to be 2/3 of x. That's all it is. Y equals 2/3 of x. How do I know this? Well, I'm going to write equations, linear equations, in the form of y equals mx. All right. What am I paying for the price? I'm paying for 2/3 of it. So if this is the price, okay, like let's say you ordered something and it normally costs $12. Okay, let me get rid of these cookies here. Okay, so let's say the lasagna, that's lasagna, normally costs $12. Okay, but because of the special they're trying to run it quickly, sell it quickly. The price I spend, y, is going to equal 2/3 times 12. And I like to put that over 1. Now, you know Mr. Lawrence is going to simplify before he divides. I'm not going to, or excuse me, he's going to divide before he multiplies. He's going to simplify. I'm going to say that 3 goes in 12 4 times, and so 2 times 4 is 8. So the lasagna today for this special is going to cost $8. That's that specific problem. All right, let's look at the second example of that. And it will be right here. And it says, a hamburger made with a certain type of beef loses 1/4 of its weight. If it loses 1/4 of its weight, how much weight does it keep? Well, hopefully you're saying 3/4, right? It loses 1/4 of its weight, so its total weight is 1 whole, or 100%, right? So there this is its weight. It's losing 1/4 of its weight. Now 1 is the same as 4/4, right? Because I need them to be like terms. I'm going to subtract 1/4 from that, and I'm going to get 3/4. Okay, so the equation for how much beef I'm actually going to eat in its weight. I don't know if you realize that when you cook meat, some of it like disappears. Okay, it boils off or steams off or runs away. Y is going to equal 3/4 times x. So let's say that, let me see here, Ellis was feeling really hungry and he ordered a 2-pound burger. Oh, that's a lot of meat, dude. You're going to be sick. Okay, that's a lot of meat, a 2-pound burger. I don't think I could eat a 2-pound burger. So how much of it will he actually be eating? Because that's 2 pounds before it's cooked. So they make the hamburger, they weigh it, it's 2 pounds. To find out how much Ellis would actually have eaten, it would be 3/4 times 2. And again, I like to put that 2 over 1, and then Mr. Lawrence is going to simplify first. So 2 is going to go into 4 2 times. So now I have 3 times 1 is 3. 2 times 1 is 2. Turn that into a mixed number, and I'm going to get 1.5 pounds of beef. You're going to be sick, dude. Trust me, you are going to be sick. All right, so this should be getting pretty easy right now. Let's go on to the third section here. All right, the number of words you can type in X minutes can be represented by the equation y equals 55x. X is the number of minutes, Y is the total number of words. The number of words your friend can type in X minutes is modeled by the graph. We better see what the graph looks like. Here we go. All right, so let me see here, Control-Shift-4. All right, got that picture. Go in here, get a blank page, drag the picture over here. Oh my gosh, it's too big. What am I gonna do? Well, I'm just gonna shrink it on down. Okay, so this is my friend, or your friend, I should say. And then the equation they gave us for you is y equals 55x. Remember, x is the time in minutes. See here. Y is the total words. X-axis is always horizontal. Y-axis is always vertical. Okay, I know I can type 55 words per minute. How much can my friend type? Well, I'm going to need 2 points. So, there's that. It's going through the origin. Hot dog, I love that. So it's going through 0, 0. And there's an intersection right there. It's going through the point 3 minutes, 150 words. Okay, so I'm going to find the change in Y over the change in X, and that's going to equal 150 minus 0. Remember, XY and XY over 3 minus 0. Okay, well, that gives me 150 over 3, and that goes in 50 times. 3 goes into 15, 5 goes into 0, 0 times. So, my friend can type 50 words per minute. Their equation would be y equals 50 times x. So I can type 5 more words per minute. So in 1 minute, I'll type 55 words. They'll type 50. Okay? In 2 minutes, I'll type 110. So like if we say, okay, here's the minutes. All right. Now, this is the words I can type. And then the green is the number of words for my friend. I coded the equations right in green and red. So in 1 minute, I can type 55. My friend can type 50. Okay. In 2 minutes, I can do 110. And my friend can do 100. In 3 minutes, my friend can do, I can do 165, right? 55 times 3. My friend can do 150 minutes. So at first it doesn't seem like a big deal, but if you do enough minutes, like if I do 10 minutes, I'm going to do 550 words. My friend's only going to do 500. How did I get that? 55 times 10 and 50 times 10. That's what's going on in these problems. Okay, let's do one last example, and then you can get started on your homework. So, let's see here. Command-Shift-4. Okay. There we go. And get a blank page. Beautiful. I have a blank page. I don't mean page pie cooch. She is not blank. No, she is a fountain of knowledge sometimes. But definitely not blank. Okay. So it says the number of miles, Y, a car travels in 65 hours can be modeled by the equation y equals 65x. Y equals 65x. If you don't realize it, that means they're going 65 miles per hour. Okay? The graph shows the relationship between distance and time for a train. Which vehicle is traveling at a greater speed? Well, I need 2 points. 0, 0. Not all graphs will go through 0, 0. Just today they are. But later on they won't. And there I have the points 1, 75. Right? Now 175, the point 1, 75. Ooh, I really don't like the way that looks. Gotta rewrite that. There we go. All right. To find the rate, how fast the train is going, I'll need the change in y over the change in x. Change in y over the change in x. And we get 1 minus 0, and so we get 75. So the equation for this train is y equals 75x. There you go. That's it. So which one's going faster? Well, the car is traveling at 65 miles per hour, and the train is traveling at 75 miles per hour. Okay, so that's it for the video, ladies and gentlemen. What I need you to do now is, if you need to, you can rewatch part of it or all of it, okay? But I need you to go ahead and do the homework. Now, listen to this carefully, please. Emma, Mackenzie, everybody, Justin, who haven't I named? Tyler, Andre, Felipe, Fred, everybody. Do your homework. Don't blow this off, because what we're going to do Monday builds directly off of this. And if you don't do this homework and don't get the practice over the weekend, you're going to come in and you're going to be lost. And then when we have another test, you're going to bomb it because you're not preparing. So please, give the homework a real effort on it. If you need some help, you can email me. Actually, this weekend's a bad weekend. I'm not going to be around. I'm going to be out of town. But you can come in and see me Monday after school, Pride Time Monday. All right? That's it for the video. Mr. Lawrence signing off. Have a good day, everybody.